welcome to Friday's edition of Cracking the Cryptic, where we're going to end the week with a puzzle called Dash, a very colourful puzzle called Dash. And this is by Alaric Taki Arancha, or otherwise known as Crusader175 over on Discord. It's got an enormously high approval rating over on Logic Masters Germany, and only 3 stars out of 5 for difficulty, which should provide some light relief after some of the monsters that I've been attempting over the course of this week. This has been a week of quintessentially exceptional puzzles on Cracking the Cryptic, so if you haven't checked out some of the videos from the last few days, just try and find the time, because there are some amazing Sudokus we've been privileged to try over the last 72 hours or so. Now, what do I need to tell you about today? A few things. I've got a couple of birthday announcements to make today. So Xochitl over in Mexico, your son Emilio has been in touch with us and said that you enjoy the channel very much. So I wish you a very happy birthday. I hope you have had a splendid day with a lot of cake. I still have some of my birthday cake left, but not much, I can tell you. I've been getting through it at an awesome rate. And that's because it has the correct ratio of icing to cake, which is 1:1, in case you were wondering. Now, the other birthday is William Wade, who turns 19 today, I think. Now, William was kind enough to invite both Mark and I to his barbecue tomorrow. Now, unfortunately, I can't do that. I have a golf competition. I'm actually not sure whether Mark can do it or not. I presume not. He normally has family duties on Saturdays, but William, thank you very much for the invite, and we hope that you've had a brilliant day today and that the barbecue goes well tomorrow. Other than that, I need to say congratulations to several very clever people who've managed to get through the doctoral pack over on Patreon at the moment. This is the Japanese Sudoku, or Japanese Sum Sudoku pack, consisting of more than 35 puzzles, and so many of you have now managed to solve all of those puzzles. So Mahose, I hope I'm saying your name correctly, I might not be, to Dennis Oken, to David Younts. David, you're over there in Vegas, one of my very favourite places on earth. I have not been there for so many years, primarily because of COVID, but it brings back some very fond memories. To Monica Reese, and to Alaric Taki Arancha, whose puzzle this is. So Alaric has not only been busy constructing Sudokus, but also solving them. So very well done on getting through the Sudoku pack. Now, I don't think I've got any other news. Mark and we're working very hard on the upcoming Domino Sudoku app. I think that will be out in days, so it's quite exciting. But there's a lot to do in the run-up to a launch of a new app, so we've been busy hinting, testing and creating puzzles like you wouldn't believe, but we're very nearly there. But anyway, let's read the rules of this puzzle. We've got the following. We've got normal Sudoku rules apply. Cells separated by a king's move in chess. I had this yesterday, king's move. Cells separated by a king's move in chess cannot contain the same digit. So let's just remind ourselves what that means. If this cell here was a 1, then neither of those cells could be a 1, because a chess king in this position could jump here and here in one move, and therefore we can't have these cells being 1s. That would break the rules of the puzzle. Neighbouring digits on a green line must have a difference of at least 5, so these are so-called German whisper lines. What does that mean? Well, it means if this was an 8, for example, this cell here would have to be at least 5 different from 8, so it would have to be a 3, a 2 or a 1. Obviously it couldn't be 13 or higher. Hopefully that goes without saying. Digits on a purple line form a set of consecutive non-repeating digits, which can be in any order. So purple lines, let's imagine this cell was a 1, then we would know that this line had to be a 1, 2, 3 triple, because it has to be consecutive digits. But we don't have to go 1, 2, 3, so it's not like a thermometer where you have to sort of increase as you move along it. You can shuffle the order, you can do whatever you like, but just make sure they're consecutive and non-repeating. Do have a go. The way to play is to click the link under the video, but now I get to play. Let's get dashing and see how we do. So we've got, what have we got? We've got two relatively long Renban lines, which are 6 cells long, so they've got to have the digits 4, 5 and 6 on them, and that you can hopefully you can see that very quickly. But if you imagine you lined up the digits 1 to 9 in a line, and then you tried to slice a consecutive set of 6 of those digits, however you did that cutting, you would always have the digits 4, 5 and 6 on the line. That's not well, or is it? I was about to say that's not very surprising, because 4, 5 and 6 are by far the most difficult digits to put on whisper lines. But actually, and the reason for that is you can never put a 5 on a whisper line, because if you do, the next digit along the line has no possible fill. We've got to be 5 different from 5, so we either have to go 0 or lower, or 10 or higher. I mean, I can't even put 10 into the software. So you can never put 5 on a whispers line, and if you put 4 on a whispers line, you can't put 4 in the middle of the line like this, because you'd have to put 9 on both sides of it. It's the only valid digit that can ever go next to a 4, and 6 has the same problem with 1. Which means that, what does that mean? So it means that in row 3, you have to have a 5 in one of those cells. Okay, well that's immediately beautiful. That's lovely. That's really lovely. Okay, so now look at row 4 and ask where 5 goes in row 4. It can't go on the whisper. It can't repeat on the Renban line it's on. So it's in one of those cells, but now the king's move comes into play. How could either of these two cells be 5? Well, they can't, because if you put 5 here, you immediately cancel the ability of 5 to appear in any of those cells. So that won't work. So the only place for 5 on this line is in the extreme positions, and the same here. So we get an X-wing on 5s in columns 7 and 9. So the question we should ask when we get this sort of pattern is where we put the 5 in column 8. Look, it can't go in those 6 cells anymore. It can't go on a whisper, so it goes at the bottom. And the interesting thing I'm seeing here, which perhaps I should have remarked on earlier, but it didn't occur to me, is look how symmetric this puzzle is. We've had some wonderful symmetrical puzzles recently, but yeah, there's almost extreme rotational symmetry here. These are slightly out of kilter. If you rotate the grid 180 degrees, this one would become that one. So you can see its colour changes, so the conditions attaching to it change. But this one is obviously doing some remarkable sort of disambiguating duty somehow. But anyway, the point is that when you have a very symmetrical puzzle, whenever you find any logic in that puzzle, you must immediately rotate that logic and apply it in the symmetrical position. So we know this puzzle is very symmetrical around 180 degree rotation, so I should be trying the same logic down here, and it works exactly the same way. We can instantly see that. Where does 5 go in this row? It's got to be in one of these 3 cells. Where does 5 now go in this row? Well, it can't now be in this string. It can't be on the whisper, so it's in one of those 3 cells. And because of the king's move constraint, we can whack those out, which means we get a 5 at the top. Exactly identical pencil marking. So now what do we do? So now this short little stubby Renban line hang on, no, I'm not quite understanding this yet. Just let me think about this for a moment. Yeah, okay, so now there's an interaction, I think, between this line and this line. Because this short line has a 5 on it, it must have a 4 and or a 6 on it. Because what are the options for this line? It could be 3, 4, 5, it could be 4, 5, 6, or it could be 5, 6, 7. Now that means there must be a digit on here that's 4 or 6 that also has to appear on this Renban line. But where does that go? So that digit cannot go there. So imagine this Renban line was 3, 4, 5. Well, then the 4 on it could not go in that position. Because if it did, you can't put 4 on this Renban line. And we know the 6-cell Renban line has 4, 5 and 6 on it. So whatever the... right, this is huge. This is huge. Because now, this line is not 4, 5, 6. Because if it was 4, 5, 6, there would be nothing we could put in here. Because the digit that we put in here, if it was 6, for example, you then can't put that digit on there because of the king's move constraint again. So that's impossible. So that means that this line is either 3, 4, 5 or 5, 6, 7, which means this digit is 3 or 7. And it means there's a sort of a close to 5 digit in one of these positions, which is either 4 or 6. And then that digit's position on this line is getting interesting. Because, yeah, okay, let's just imagine for a moment this was a 6. If that's a 6, where do you put 6 on this line? The answer is exactly here. And the same would be true if this is 4. It would have to shift here. And if this was 4, you'd have to put the 4 here. And if this was 6, you'd have to put the 6 here. So that reflects down into this row. So now there's the weirdest sort of floating X-wing. There's an X-wing on 5s, and there's an X-wing on 4 or 6 in these positions. Or maybe I'll highlight that like that to try and remind me of that. And that 4 or 6 X-wing. Yeah. So imagine it was an X-wing on 4s here. Well, that would put a 4 in one of those cells. You can't put the 4 in the middle of the whisper. Because if you do, you have to put 9 on both sides of it. And if it was a 6 in those cells, you'd have to put 6 here and then 1 on both sides of it. And that won't work from a Sudoku perspective. So that means these cells are now... So the floating X-wing gives rise to a yellow in one of those up there. And that logic is totally transposable over here. So we just rotate the grid and do it again. So that means these cells are from 4, 5 and 6. These cells are from 4, 5 and 6. And there's a floating X-wing over here as well. Actually, maybe we don't need the highlighting, the colour highlighting. Now this digit, the equivalent of that digit is there. So that's 3 or 7. And that digit, oh yeah, this is lovely. This is lovely. Right, where does that digit go on this Renban line? Well, the answer to that is nowhere. And that's important. That's why this is why this couldn't be 4, 5, 6, is because this cell can never appear on this Renban line. But now this is a 3 or a 7 and it can't appear on this Renban line, and that's enormously powerful. Imagine this was a 7. Now you can't put 7 on a 6-cell Renban line. So that Renban line must be 1, 2, 3, 4, 5, 6 because it's consecutive digits. If this is 3, you can't put 3 on this Renban line. So it has to be 4, 5, 6, 7, 8, 9. So this colour, whatever this is, this 3 or 7, is going to determine the extreme nature of the Renban line that's above it. Now, what does that mean? So that means whatever this is. So let me just think about this. If this was 7, this line is now 1, 2, 3, 4, 5, 6. If this is 7, this is a 4, 6 pair. No, not 4, 6 pair, it's a 5, 6 pair, sorry. So if this is 7, this is a 5, 6, 7 triple. Right, I understand. Yes, okay. So if this is 7, that is an 8-9 pair. And that's because the thing I didn't mention about whisper lines, the only other secret I have about whisper lines, is that there is an oscillating polarity about their nature. So we talked earlier about how you couldn't put 5 on a line and how 4 and 6 were difficult to put on the line. But the fact you can't put a 5 on a whisper line means you can always divide a digit, the nature of a digit, into either being a low digit or a high digit. So it's either a 1, 2, 3, 4 on the whisper line, or it's a 6, 7, 8, 9. So imagine this was a 6, 7, 8, 9 for a moment. What's this then? And the answer is because it can't be 5, it flips to the other type of digit. It would have to be lower than 5. Because even if this is 9, we have to deduct at least 5 from it. So we get to 4, which is the other side of 5. And the same would be true. It just continues like that. So then if this line continued here, you'd then need to have a digit that was 6, 7, 8, 9 again. So what that means is if we think about row 4 again now, if this is 7, this is 5, 6, 7, this line would have to be 1, 2, 3, 4, 5, 6. So I've got the task of putting 8 and 9 in this row. But they can't go in adjacent cells on a green line because the line oscillates in polarity. So those two cells have to be the same as that cell in terms of polarity. And I'm just going to double check that and prove it to myself. Because if this was 3 on the other hand, let's work out what's going on then. If this was 3, this would be a 3, 4, 5 triple. You then couldn't put 3 on this line, so this would be a 4, 5, 6, 7, 8, 9 line, which means in this row we've got to think about where 1 and 2 go. They'd have to go on the green line, and they can't go in adjacent cells. So this would be a 1, 2 pair, with that being a 3. Yes, so the polarity of row 4 is, well, it's really nice, this. So now this cell is blue. And it's the same polarity as this, but the problem is we don't know whether this is high or low. This 1 is somehow going to do the work here. So this, if this is 3, this is 1, 2, it might actually be more likely that this is, if this is 7, this is 8, 9, this is high, so both of these would have to be low, and I'm wondering if that gets into more problems with the 1. I'm not sure. Okay, but what we can go further, can't we, in row 4 when we think about polarity now? Yeah, actually we can go loads further. This is lovely. Right. What we can now effectively colour the whole of row 4 from a polarity perspective, because we've got 3 digits of the same polarity here. That means there's 1 digit left of that polarity, because obviously if you had 7, 8, 9, you've only got 6 left, for example. But we know that digit that's the same polarity as this, that's not these two cells, is in one of those cells, because we know this is either 3, 4, 5 or it's 5, 6, 7. So if this was 7, we know there's a 6 in one of these, which is the other high polarity digit. And that means that these cells, which cannot be 5 because the 5 in the row is there, all have to be low. The whole of the rest of that, these orange cells are the opposite polarity to blue. And these two are also orange, obviously, because of the whisper line oscillating. So now I want to say, do I know what that is? And the answer is, I don't know. That, yeah, I don't know. If this is 7, this is 8, 9. What's that then? This is 8, 9. So this is 1, 2, or 3. If this is 7, this, oh, I'm getting really confused now. It's very difficult to do this. I think it would almost be easy to do it if I was just to guess what this was. But I know people don't like me doing that because they say it's bifurcation. This is an example where I don't think this is bifurcation. This is, I understand how the puzzle's working, if you see what I mean. I've deduced a lot of logic. What I'm struggling to see is the natural implications of this. But I'll try and do it without using a placeholder. Hang on. Let me think about this. So I know one of these is blue, and one of them is 5. And then if I've got 3 of the same so if this is 7, these would have to be from 1, 2, 3, and 4. But I know this line has 1, 2, 3, 4, 5, and 6 on it. I know this would be a 5, 6. Yes, okay, so that's orange. Sorry, that's important, isn't it? Yeah, okay, so let me go through that again. I think it's right, but I'm just going to go through it slowly just to check. If this is 7, we know this is a 5, 6, 7 triple. And therefore we know this line consists of the digits 1, 2, 3, 4, 5, and 6. Now, we know these 3 digits would all be low digits because they're the opposite colour to 7. So these are all low, and we know these 2 digits are the same as the 5, 6 pair here. So this is a 5, 6 pair, and these are all low, so that must also be low because we know that we have to have all low digits on this line. Yes, okay, so, and now this matters for this line, which, if we look at how this is going to oscillate its polarity, if these were both orange, we'd have 5 oranges in the row, and that's impossible. So we can't have that. We must have the orange in the middle, surrounded by 2 blues. And somehow, some way, this needs to... What I can't see is how this 1 is fixing the world. Oh, the other thing I can do, of course, is rotate this. Oh, bother. Yes, right. What we need to do now is instantly rotate this. All this logic here that we've just done is instantly rotatable onto these lines, which are exactly the same logic. But what does that do? Well, look, the logic of these lines is going to make these 3 cells the same colour. Now, what can that colour be? Well, it can't be orange now, because if those 3 are also orange, there are 6 of the same polarity digit in box 5. And if this is low polarity, that would mean these digits would have to be filled, these 6 cells would have to be filled with the digits 1, 2, 3, and 4. That will not work. And if they were high polarity, they'd have to be the digits 6, 7, 8, 9. That still will not work. So this must be opposite polarity. So this must be blue. That must be blue by that logic. This must therefore be orange. Now that means these 2, I think, they're the opposite polarity to these. So they get blued, and they are surrounded by oranges. So we get this polarity, and we can carry on the polarity here as well. Orange and double blue. And now I think this line... Yes, so we do the rotation, and then we flip the polarity, and we get something that looks... So now, 5 in the middle box. Oh, we... Okay, yeah, we could have got that before. 5 is in one of those cells, because 5 is here, and 5 is here. We didn't need to know that these cells were not 5 in order to work out that 5 goes in the middle. If we had a brain. Okay. So this is great, I think, but what it has not done What it has not done is told us the nature of orange or blue in this box. Because the 1 is going to have to do the work. I need to sneeze. Don't sneeze, that would be a disaster. But now we know if this is 7, this is 3. And if this is 3, this is 7. So let me think about this. So if this is 7, this is 3. These would be that would be a 1-2 pair in that instance. I'll just show you that. If that's 7, because that's then 3, what do we put into this domino now? Well, you can't put 4 in the middle of a whisper because you're going to have to surround it by double 9. We've already looked at that. So if this is 3, this has to be a 1-2 pair. 1-2 pair in orange. So orange is low polarity, so these cells would have to be these would have to be low polarity but not 1. And this is very annoying. You could put 4 in there. Normally you can't put 4 in the middle of a whisper line, but you can here, because if you put the 4 there, the 2 9s that must flank it don't see each other by Sudoku, so that's very annoying. So this is a 1-2 pair. Right. This is right. This is right. I've now got it. I understand how the 1 does it. This is really beautiful, actually. Alaric, this is beautiful. Now, let me try and explain this in the key is really this cell, I think. So if we're in this paradigm where this is a 7 and this is a 3, because this has to be a 1-2 pair, this cell becomes very interesting. Because this cell has to appear, it's a low digit, so it has to appear on this Renban. Well, where does it appear on the Renban? The answer is there, because it's not in those 3 cells. So if this is a 1-2 pair, this is a 1-2, and now look, I get a 3-4 pair here. Now why is that interesting to me? Well, if this is a 3-4 pair, what does that digit have to be? And the answer is it has to be a 9, because it sees a 4 on one side of it. If this is a 4, that's a 9. If this is a 4, that's a 9. Why does that feel like it's making a difference to the world? Well, let's try this the other way round and see what happens. So if we were instead to go, oops, where's it going to unwind? Right, so if we go 3 here and 7 here, I think what we're going to find is that we have to put a 1 in one of these cells. But let's see. So now these cells now, which are the same polarity as 7, which means they're from 6, 8 and 9. They can't be 6 because they'd be flanked by double 1. So this is an 8-9 pair. This 8-9 has to appear now on this Renban because this Renban here doesn't have a 3 on it anymore. So it's made up of 4, 5, 6, 7, 8, 9. That 8-9 has to go here therefore. This is an 8-9 pair. This is a 6-7 pair now. Now where's this? One of these is a 6. So this square is, you've guessed it, a 1. Has to be 5 away from 6. And that crashes the puzzle. Wow, wow, wow. So this is it. This is it. Well, I'm not going to say we've done the puzzle, but we have now, I think, made a huge step forward because we've proved this is 7. This is 3. This is a 1-2 pair. This is a 1-2. This is a 3-4. This is a 9. And now, well, okay, so now I want to look at this cell. Because this cell is a low digit, which means it's a 1, 2, 3 or 4, but it can't be 3 or 4, because if it's either of those, it knocks itself out of those cells and would force these cells to be a repeated digit. So this cell here, which is low, has to be a 1 or a 2. It gives me a 1-2 pair in the row, which means these two squares are a 3, 4. Ooh, that's a bit deadly-ish. Okay, no, maybe it's not deadly, because maybe it gets resolved by this digit. That will put pressure on this cell and could unwind what might otherwise be a deadly pattern. But I've got 3 and 4 now on this line, so I can't repeat 4 on it. So those 4s come out. We know that this is a 7, so we know that this is 5, 6, 7 triple. And then we've got another deadly pattern over here on 5s and 6s. But that is going to be resolved by... Oh, what's that going to be resolved by? I don't know, actually. Have I made a mistake here? Oh, I've got king's moves as well. Oh, okay, forget all the stuff about deadly patterns. King's moves will probably help us. That's a relief, because I was suddenly thinking I was not going to have a way of finishing the puzzle. So this is 8, 9. In this row we need a 7 and an 8. Now this being 3 means we can dispense with the need to use 6s in this string, which means that this also doesn't have 6 in it, does it? So this gives us our deadly pattern down here on 4s and 5s. Take 6s out of the top. Now, it's weird. It's weird how just the rotation of the logic throws me. It's thrown me for a minute, but this is a 1-2 pair, isn't it? This is a 1-2 pair because this line is now full of high digits. So I've got to put low digits in this row. So this has to be a 1-2 pair. This square here is now something. It's the equivalent of this. Oh, I see. But yes, that's fair. That's fair. You can't put 6 in here. This is high digit polarity, and you can't put 6 in the middle because you'd be flanking it with double 1. So this is an 8-9 pair. The logic does work. It is symmetrical. So now we shall argue about where 8-9 goes on this line. It's got to go here, which gives me the 8-9 pair, which is the equivalent of the 1-2 pair here, which means these squares are 6 and 7, which means one of these is a 6, which means this has to be a 1, which means that's a 2 now. That might be big. Yes, look at that. That goes through the rem band to here. Or maybe it's not actually. Okay, I thought that was going to be jolly exciting. It was a little bit exciting. And I'm reckoning that I might be able to get this digit, just looking at the fact I've got all these dominoes done. So I reckon I might be able to get all these dominoes done just by completing the symmetrical logic. Let's see. So, how do we do this then? If this is 8-9 and this is 8-9, this digit can't be 6 or 7, look, because it would rule itself out of both of those. So that, I see. So that's 8-9. It sees that square. So that is 8. That's 9. That's 8. That's 9. And we've got our dominoes at the bottom of the grid as well. We know these squares have got to be 6, 7. And we've got... And we know, right, so the middle 3 digits we now know are 1, 5 and 9, I think. 1 has to go in this cell, 9 goes here, 5 goes here, using the power of Sudoku. Outrageous, Crusader 175, to make me do Sudoku only half an hour into a puzzle. This 9 sees that square by king's move, let's not forget that. So that all gets filled in. The 1 sees this square by king's move, this gets filled in. I've not put in the options for these. I should be able to, looking at, yes, okay, I can just use Sudoku to help me, can't I? I need to put 3 into one of these and 2 into the other. So 2 must go here and 3 must go here. And 2 is on a whisper. Can't be next to 6. 6 is only ever next to 1 on whispers. So that's 7. That's 7. That's 6. That's 6. And this 6 is only next to 1. So that works. So now I reckon I should be able to repeat that up here somehow. The 8 can't be next to the 4. So that's a 3, that's a 4, that's a 4, that's a 3. It's just wonderful, isn't it? It really is wonderful. So I'm left with 4 5s not being disambiguated and 5 6s up here. I can get rid of the corner pencil mark 5 there. 7 has to live in one of those cells, and I suspect it's just going to be some Sudoku now. Yeah, okay, that's a 3-4 pair. So at the top, I need a 6-7 pair. Oh, nearly. I thought I was going to be able to rule out a high. If I could rule out high from there, I would know this would have to be a 2. Bother. Okay, I can't do that. Sorry, I'm not seeing how to do this now, and it's going to... Oh, bother. How do we do this? Right, let's fill in some more digits in the middle row. These squares have got to be 2, 6, 7. And that one can't be a 7. And that one can't be a 2. And that one seems to be able to be anything. And that one isn't seeing anything by King's Move. So, right, that's no good. Let's look over here then. We need 3s, 4s and 8s. So that's not 8. That's not 3. That one's going to be able to be anything because it's just the opposite of this one. Oh, here's something. 9, 9. Where does 9 go down here? If 9 goes on this little wren band, we have to put 8 there because these have got to be consecutive and we can't. So 9 is in the bottom cells. Right, so it's going to be about these little tiny wren bands and whispers. 9 is here. Okay, King's Move. You can't put 9 here, so 9 has to go there. So 9... 9 is in one of those cells. Now, if 9 was here, this would be 8, but that looks not impossible, unfortunately. Okay, let's think about these cells then. These have got to be 1, 4 and 7. Oh, bother. I think that's... okay, I was wondering whether this cell was going to prove mighty, but I'm not sure it does. That can't be a 1. Oh, no. Okay, we've got to keep going on this, I think. Right, what about this column? I've not put 5 in that column. It's got 2 whispered lines in it. Well, that means that's a 5. Okay, so that's good. That gets us more digits. Not a lot more, but just a few more. So what else are we left with in this column then? 2 and 8. So this is a 2-8 pair. Okay, now 9 has to be in one of those cells. Now that looks interesting. So if this was a 2, this would have to be a 9. If this is 8, this has to be a low digit, which would have to be a 3. I think we've got the same thing. Right, let's carry on doing Sudoku. Let's see if that helps me. Okay. I don't know. All right, now I'm going to look at column 6 instead. So I've got 2, 5 and 8 to place. So 2, 5, 8. Now, unfortunately, everything there has an option that's valid. 2, 5, 8 here. Can that be a 3? No. Okay. This can't be 2 because this would need to be a 1 or a 3. So that comes out of there. So now, if this is 8, this needs to be 7 or 9. I think they are possible. If this is 5, this needs to be 4. It can't be 6 actually. Can that be 4? No, that's it. Right, this one. This sees a 5, 6 pair, so it sees 6 and it sees 4. So I don't think this can be a 5. This has to be an 8. And then this has to be 7 or 9. And unfortunately, by hook or by crook. I think both of those seem possible. So now this square is a 2, which means this is a high digit, and it's not 7, 8, and it can't be 6 because 6 would need to go with 1. So that does become 9. So which knocks 9 up here by Sudoku. And now we can presumably do more magic. Let's see. We can knock 8s out of these. So that can't be 7 anymore because it needs to be consecutive now with just 2 or 5. 1, 4, 7, 8 into this column. So this is just 4 or 7. It's not seeing anything. So, oh, I see. Where does 8 go in this column now? It has to go here. Gosh, it's quite tricky, this. And in this column, I need 2s, 3s, and 4s into those cells. And that's not a 2, so the only place 2 can go is right at the top. Oh, I've just seen, look, this is a 2, so that's a 5 as well. So that's a 2, so that's a 1. And that might be cool. What about what's that's doing over here? So 1 is now in one of 2 places. Can it be on the whisper? Yes, if that's an 8. But it, oh, and it is an 8. Ah, okay. So this is low. And it's not 4, so it is 1, 2, or 3, and it can't be 2. So it's 1 or 3, and it... Ah! All things are possible, I think. Bother. Okay, what about this box then? 1s, 3s, and 6s. Can we do something good with that? Maybe. What? Oh yeah, maybe. Yes, that cell. 1, 3, see that cell? That's 6. Which fixes the 6 and the 7. That 5 is fixing this 5 and 4, which I hadn't noticed, which fixes the 3, 4, 3. So now that fixes the 3 and the 1. This is going better now, isn't it? So this has to be a 4 or a 7, which is... Oh, how is that going to get resolved? Oh, I was wondering about the deadly pattern, but the 7 here is doing it. So 4 goes here, 7 goes here, 7 goes here, 4 goes here. We need to put an 8 in this box. How many 8s have we got? Loads. Nearly all of them. I should be able to get the last one. It goes here. This 1 is not doing enough. This is 2... Oh, no, although it is putting a 1 in this cell by Sudoku, so I was maligning it unfairly. Oh, this 4 is now doing work. 4 and 3 go into the grid. We need a 7 in this row. So that's not 7 anymore. This is 2 or... Oh, okay. This is 2, 3, and 6. Scanning the column to see if this is resolved. I think it must be. I'm sure it's resolved somehow. This is looking a bit odd. Oh, I've got a 2, 6 pair here, apparently. Oh, 6 here. There we go. 2, 6, 7, 6, 2, 3. It still looks like it's working, doesn't it? Why is this not resolved? Oh, this 5 is doing it. Good grief. Okay, so that all gets fixed. And this 5 does it the same job on the other side, and that's the puzzle. Yay. Fabulous. Absolutely fabulous. I don't know, is that 3 stars out of 5 for difficulty? It's right on the cusp, I would say, of that being 4 stars out of 5, because I think there's quite a lot you have to think through to understand how these lines work. But they're quite beautiful. It's an absolutely awesome setup. And the fact that you can then back into the importance of this 1 and work out that you can't have a... because if you went through the other paradigm, you would have to have a 6 in one of these, and that would force this to be a 1. It's just beautiful. It really is. I'd be interested in the comments on this one and how you found it, whether you've flown through it or whether it was sticky. Let me know in the comments. I do enjoy them, especially when they're kind, and we'll be back later with another edition of Cracking the Cryptic.